Part 2 of the exam. So we are asked to draw a circuit diagram for a Boolean expression. The expression is f equals ab negative XOR C all knotted. Using transistors, NPN or PNP, 5-volt power supply, and ground. So how did I go about doing this? The first thing I did is I took the expression and created a truth table for it. So in the first three columns here is my ABC, and the second 3 columns is my ABC knotted. Then I began with the just AB knotted and came up with that value, and then I XOR'd in C, came up with this value, and then when you knot everything together it comes up with this value. So to get to this, what I did, and I'll scroll up here a little bit, is I took all the values from my truth table in this column here and put them into this K-map here. Okay? And this K-map, as you can see in the red, the green, and the blue, gave me this equation. So A naught, which is this row, C, which is everything in the orange here, and then B, which is everything in the green here. Now to confirm that, because I don't want to just believe everything, so I came over here, and what I did is created my 3 rows for A, B, and C, and created a the OR equation. So let me go back here to this. So here's my equation again, A naught C B, and here we have A naught, B, and C. So when I have A naught to 0, or A to 0, and regardless of what B or C are, I should always get a true, and I should always get a false on A naught to 0, 0. So now it's A naught, and we go B positive, C positive, C0, B0. Okay? And then the other thing is down here in this region here, so I will actually highlight it for you like this. Okay? In this region here, this is a decoder. So if you look at how each one of these AND gates is set up, it is attached to a line either on A or A naught, and it's decoding each value. So the one value it should always say is false is this here, which is A, and then B naught, C naught. Okay? So when we click and we let go of that highlighting, you'll see that that's 0 and it matches this up here, which is 0. So if we then set this to 0, that lights up, and everything else will light up right along with it. So the 2 LEDs match. And as long as the 2 LEDs match, we're golden. Okay? So that gets us to our equation of f equals A naught, B, and C. So now the question becomes, how do we draw our diagrams? Okay, so we have A to A naught here, which is our CMOS NOT gate. So we have that, and then we have our OR gate here, which is ORing everything together. And I actually had to look this up to make sure that my guess was correct, that this is how you OR everything. So I OR'd everything and we come up with this, but now this is knotted. So in order to get rid of that, we have to pass everything back through another OR gate, or another NOT gate. So here's our input for that NOT gate, going into our CMOS NOT and then coming out, and there's our equation. So if we go back up to the top here and we read, we have transistors, N and PN, which we both used. We have a 5-volt power supply, and we have a ground. Now, for one last check, what I decided to do, let's see which one is up here. Here is our KiCad. So I drew this in KiCad. And here's my 5-volt power supply. And here's my switches for A, B, and C. So A is being fed into this gate here, and we get A naught, and so here's A naught with B, and that should be C, sorry, coming in. And then we have A naught, B naught, and C naught down here, and then here's our output equation with our input going into the last naught and coming out as an output. And then if you want to make sure that that actually works, you can run it through a DC operating point simulation, and it'll actually give you values showing that everything came through. Minus, of course, that one correction there, which should be C. So, hope you learned something, and have a great day. Bye-bye.